Hi, today I just wanted to create this reference for size delta. It's a property of RectTransform in Unity, and it is very hard to find resources for it. So I wanted to provide a reference for it just to explain how it works. Basically, I mean, it sets the size, but there's a bit more to it than that. It's not as simple as saying I want a width of 50 and a height of 50. There's a lot more to it than that you have to take into consideration. So we can look at the docs. That's a good place to start. It's almost useless, the docs. It tells you that size delta is a public vector 2. That's very useful, but it says the size of this rect transform relative to the distance between the anchors. That's gibberish. If the anchors are together, size delta is the same as size. That's very useful. It's very important. If the anchors are in each of the four corners of the parent, the size delta is how much bigger or smaller the rectangle is compared to its parent. That's gibberish to me. To be fair, this is pretty easy to figure out, but at least if you're as dumb as I am, then it's nice to have a reference for it to give you some place just to start. So just two notes to get out of the way. First of all, this is just about what size delta does, how it works. This isn't even about when you should use it. This is just how it works. And that's all I want to talk about in this tutorial for the most part. That said, we do need to have a quick little section on RectTransform. Just a little bit of a primer, just because there are a couple of things that you need to understand in RectTransform to be able to use size delta. First of all, you have anchors, so you can see here, you can tell Unity how to anchor game objects to their parent. In this case, we're anchoring to the right hand side of the parent, as well as stretching to the top and the bottom of the parent. The anchor you choose, or the anchor preset you choose, will change where your anchors are. So these little white triangles, they are your anchors. So if we chose to anchor in the center, well, you know, surprise, surprise, we're in the center. That matters because it changes these fields, okay? So basically, if your anchors are in the same spot on the x-axis, which they are in this case, you get pos x and width. If they were in different places on the x-axis, so if I move this, then what you can see is now we get a left and a right field instead. Put that back. Exact same thing for the y-axis. If they were on the same spot on the y-axis, that you would see pos y and you would see height. Because they're not on the same spot on the y-axis, you see top and bottom. So our size delta, it has an x value and a y value. Essentially, x will control width if you have it, or it will control left and right if you have it. And same thing for y. Y will control height if you have it, or in our case, we have top and bottom, so it's going to control top and bottom. The way top and bottom work and the way left and right work is they control negative space. So with width and height is really easy. You just literally tell it the width and height you want here in the inspector. So I want this to be 430 pixels, so I just put in 430, easy. But if I want to use these, I'm telling it how much space not to take up, okay? So essentially, if I put in 50, what I'm saying is, so the way the anchors are set up is this is stretching all the way to the top of its parent. But if I put in 50, what I'm saying is stretch to the top of your parent, that's good. But just leave 50 space between you and the anchors. So you can see 50, right? That's how much space is here. Same thing on the bottom. I can put in, let's put in 70. And then it's going to be 70 space between itself and the anchors. So they control the space you're not taking up. And that's important to note as well. Our y value is going to be, in this case, 120. Actually, it'll be minus 120, but it'll be 120. It'll be these two things combined together, and it works exact same way for left and right. Right, if our left value was 50 and if our right value was 70 or vice versa, we'd have 120 as our x value in size delta. Hopefully that makes sense. It will in a second if it doesn't when we get into the code. It's just important to know that top and bottom, left and right, they control negative space, and it's not the same as directly telling the game object what height to be or what width to be. The first thing I kind of want to do, we're going to do three things to really learn how to use size delta, what it does. First thing I want to do is I want to tell Unity just to set the game object's width as 430. Now I got it already pretty set up in here. I already have my rect transform that I can access. So literally all we're doing in this case, which is pretty simple, is we are just going to say text panel So this is the object, or this is our game object, and then we've already said to get the RectTransform component. Again, I'm not going to go into this because it's not the point of the tutorial, but essentially this is the same as accessing any component of any game object. But what we need to do, actually we need to say dot size delta equals new vector2. So what values are we going to put in here? For the top and the bottom, since we do want this game object to stretch all the way to the top, all the way to the bottom, and we don't want to tell it not to take up any space, we can do one of two things. We can put in 0. And we can put in 0 because 0 is already here in both fields, so it's fine. Don't worry about it. 0 works. Or we can put text panel rt.sizeDelta.y. And both of these will work. Both of these will work fine, no problem with either. You just have to understand what they do. So 0, we're literally telling it 0. So if we put in 0, this will be made to stretch to the very top and the very bottom. It will put 0 on both of these fields. If we put here, however you named your reference to RectTransform.sizeDelta.y, basically you're saying whatever it is, don't change it. So if in the inspector we set this to 50 and 50, if we had 0 in this space, it would change to 0 once we ran this script. If we had what we have now, it would stay at 50. So that's all you really need to know about that. So I'm just going to leave it at 0. Doesn't really matter in this case. But because we have an actual width field, and remember, in the docs it says, if the anchors are together, size delta is the same as size, okay? So because we actually have this field here, in this case it's really easy. We can say 430. And if I do that right, so we save that, you can see now the width is 430. So that's pretty easy. So what if I want to set the height to be 500 and I want to keep this anchoring preset? Well, there's no height field, is there? So I want to show you the one resource I found that was actually helpful. There's a video you can watch. I mean, it's about building interfaces in general, and in this case a bar graph, but it's about the whole topic in general. It's not specifically about size delta, so I only watched some of it. I don't know how in depth it goes into size delta, but it shows you a lot of things about like instantiating and stuff like that, it seems like. But this post is really helpful. Essentially, I mean, I'll link this in, you can read it if you want, but what we kind of need to know is just this section here. So rectangle defined by its anchors, those triangles, normally related to the parent object location and dimensions, in this case the canvas. That I can understand. And then we have the rectangle defined by its own size, the panel's own dimensions, or dimension. That I can also wrap my head around. So size delta equals b minus a. So that's really, really useful. And that's what we're going to use to set a height of 500. So we're back here in the code. So how do we do this? So I already set up an int called int text panel height, but we need to make that equal something. The height is what's left over from all the space you're not using, if that makes sense. So what you need to know is you need to know the screen size. So in this case it's 1080p, and we're gonna just use the screen.height, but in this case it's 1080p. And we know we can tell Unity how much space not to take up. So we want 500 space being taken up. So the difference is 580. So we know we don't want to use 580 space. And if we don't use that much space, we'll have 500 left. Okay? Hopefully that makes sense. But what we're going to do is, I'm going to do this and start just first. But what we're going to do is I'm going to say text panel height equals 500 minus screen dot height, and that's the same as saying 500 minus 1080p, and that's going to give us the space we're not using, and that's the same as this, right? So we're doing b minus a, so b, the rectangle defined by its own size, so that's 500. That's the size we want. And then the rectangle defined by our anchors. So in this case, the rectangle defined by our anchors is the same as screen size, or screen height, I should say. So that's why I'm using screen height. And that's going to give us a value of minus 580. So that's exactly the same as if we put minus 580 here. It's negative, like if you were passing an absolute value, like if you were putting a number in there, you have to make sure it's negative if it's going towards either left and right or top and bottom. Just because if you put a negative number in, you'll get positive values there. And the reverse is true. If you put a positive number here, you'll get negative there, and you don't want negative in the inspector. So negative here, but in this case, we're just going to use the variable we created, and I'm going to paste that in. So I'm going to save that. So what you can see is we're telling Unity to not use 290 pixels from the top and 290 pixels from the bottom. So if I change my anchoring to something where you can see a height, you can see we have a height of 500. Now the one thing to note, because we put it in start, so you can see we're still not using 290 pixels from the top and 290 pixels from the bottom. But what's happened is, since we only have 720 pixels in total, that makes our game object a lot smaller than 500. If we go to here, you can see it's 140. And that's because since it's we put this code in start, it's not updating. It's still thinking of the height as 1080 when it's actually 720. So what we do about that is we move this down in the update. Now we save that up. So now you can see we have these values of 290 here. If we go to 720, you can see they've changed to 110 and 110. And this is 500 pixels again. Now what we can't do, because we moved into the update, is we can't change the anchoring to something that's going to mess it all up. You can see in scene, it's all messed up because our height is now minus 220. And why is that? Well, we are passing a value of 220, minus 220. You can see these two equal 220, and then it becomes negative. The reason we can't change anchoring when our code is in update is because we're continuously giving it the value, in this case, of minus 220. And that's not good. When you have a height field, it doesn't want a value of 220. Or negative 220, I should say. It works really well when you have top and bottom. So when it was in start, we only gave it that value once, and Unity is good enough to be able to update it to something that the new anchoring can use. So if it will come out of play, and if I go back into 1080p, and if I put my width back to what it was, right, if I put 290 and 290, and I go into here, it's able to change that over to 500 in the height value. So Unity is able to handle that itself. But when you're constantly telling Unity, hey, I want a value of minus 580, or I want a value of whatever, that's going to update in the height value, or the height field instead. And it's going to mess everything up. So the important thing to note is if you have this code in start, then you're not able to change your resolution because Unity won't know to update the screen height. Is going to keep going based on 1080 or whatever your first screen height was. And that needs to update so that this equation is constantly able to give us a height of 500. When we put this in update, we can't change the anchoring because it's going to keep giving a value that's only meant for top and bottom into the field, even if we've changed it to a width field. It's just something to be aware of, because like in the inspector, for example, if I set this to center, it's not going to work. It's going to mess up. You changed your anchoring, you might have to update your code. Well, you would have to update your code actually. So the last thing that I want to talk about, that I want to show you, is you can see this game object is right in the center on the y-axis, right? So our y value in size delta is being distributed evenly between top and bottom. And what would you do if you wanted to put this closer to the top or closer to the bottom? Well, the best way I found would be to change the pivot. So for example, if I put the pivot up higher, you can see now we are much closer to the top of the screen than to the bottom. So these two fields still equal 580. It's just how 580 has been distributed amongst those two fields. So how do we do that in code? Well, there's two different ways we can do this, but first what we need to do is we need to type in dot pivot equals new vector 2, and what we also would want to do is actually not that, is say text panel rt dot pivot dot x, because in this case I don't want to change the x value, so that just tells it keep the x value the same. So we could put a pivot directly here like this, right? We could save that. It wants an f because whatever. So you can see that works, and you can change where it is on the y-axis that way. If you wanted to set it as a specific amount of pixels from either the top or the bottom, you can do that using proportions. Essentially, let's say it was 80 from the bottom or 80 from the top. These are the proportions you would use. So all this really is this is where you want it. This is how far you want it from the bottom. This is the size delta y value. So you're saying out of this y value, 80 of that is what is our proportion, right? That's what we have. And this is our pivot. So essentially our pivot is only ever going to go to 1. So this pivot y value, we never want it to be more than 1, because that spans the entire object. So 0, our point of origin, this blue circle is down at the bottom, and here it is at the top. And we want our point of origin to be within the object, so we don't want it to ever be less than 0 or more than 1. So that's why our pivot value is going to be, it's going to be somewhere between 0 and 1, which is another way of saying it's going to be something out of 1. If you're a little rusty on proportions, you can check this out. I'll link it in, but basically this just is a math.com lesson on proportions. But essentially the math we're doing is we're doing this value, so whatever we want from the top or bottom, times our pivot, our maximum pivot, divide, take that result, and then divide it by our delta size dot y value. So I have a y value float, and it needs to be a float because it's a decimal. But all we're going to do is going to say y value equals 80 divide, I should put the f, divide by 580f. And you need to make sure that if you are representing this as a variable, that your new vector 2 is actually taking that variable. So you can see now we have 80 from the bottom and 500 from the top. So our 580, that is our delta size y value, sorry, our size delta y value has been distributed so that our game object is much closer to the bottom, right? So if you wanted to set it from the top, same deal, except you would change this to 500, and that would set it 80 from the top, because basically what you're doing is if you want it from the bottom, put the value you want. So if you want 80 from the bottom, put 80 here. If you want 80 from the top, then you put the remainder. So what I mean is we have 580 is our size delta dot y. So you take away what you want, and then what's left, that's what you're gonna use. The other way you could do it is you can always reverse what you have just by doing y value equals 1f minus y value, and that'll reverse it. So the way we have it set up now, this line will give us 80 from the top, but this line here will make it 80 from the bottom. And conversely, if we had this set up for 80 from the bottom and we had this line, it'll change it into 80 from the top. So I put this back to 80 and save that. You can see we have now 80 from the top. It reversed, right? So that's how you can do that. The one thing to note is it is proportional. So what I mean is if we hop over here, the pivot stays the same, but these values change, or these fields, I should say, change. So percentage is the same. So the top is the same percentage of your y value, and bottom is the same percentage as y value, no matter what resolution you go to. But it just updates these fields so that they are more appropriate to whatever resolution you happen to be switching over to. And it's good because it'll make sure your game object is in the same relative space on every screen. And it's also good because let's say we said, oh, well, let's make it 760 from the top, right? We want a pivot that's going to give us this value. If that value stayed, if the 760 value stayed, you can see it's not so bad here, right? But if we went into 720 and we had that 760 value, well, the 720 resolution doesn't even have 760 pixels from top to bottom, so you're not really gonna be on screen so well, right? So you want this these values updating every time you change a resolution, but you want the pivot to stay the same, and that way it's the exact same thing every resolution. Is just proportional so that it will never go off screen. Hopefully that's helpful. Hopefully that's a good lesson on size delta. I tried to cover everything I thought would be important in a reference to getting started with it for the first time. So I do hope I got everything. I hope that helps.